Hello everyone, welcome to JC Connect. Today I'll be discussing on trip distribution and various methods of trip distribution, trip matrix or OD matrix in detail. And in the earlier presentation we had seen trip generation. What is trip generation? What are the different types and the factors affecting trip generation, category analysis, right? Regression equations, right? So now the after trip generation, the once the vehicles are moving out of their maybe home based trip or a business trip, hmm, we have discussed that is home based trips, home to home, home to office, then non-home based trips, that is office to another office, or office to another workplace, workplace to other uh, locations, maybe recreational activities for that purpose or n number of purpose they are going out, mm, or you can say business trips, the non home based trips, those things we have discussed. So here the that is generation is from whom you are coming out. Hmm. That's what I have mentioned here in the trip generation. That is for a certain purpose you are coming out of the house. That is the decision to travel. The decision to travel maybe for school going purpose, for job purpose, for education purpose, for health uh, purpose. You are coming out, of the residential area or a residential zone, and you are making a trip. So that is trip generation. So here in trip generation we have seen that is after having obtained an estimate of trip generated from uh, and attracted to various zones, it is necessary to determine the travel of direction of travel. So this is direction of travel where in trip distribution we need to emphasize on this, right? So here the these trips generated trips from each zone is then distributed to all other zones based on the choice of destination. Choice of destination is with respect to whatever, whether it is a home, office, college, right? Uh, so different purposes, with different purposes you have made the trips, from home. So those distribution, how it is going to take place and how that is going to affect the travel pattern. In travel demand modeling, it is going to help us, right? So for that purpose this distribution trip distribution study is very important. So when we want to distribute, there is a origin and another one is destination. So origin and destination, you are started from here, right? And you are going to end your trip here at the say college. So here the in before we discuss all other n number of trips from various zones to other different zones, you need to understand the OD matrix or a trip matrix, we can say. So this uh, trip pattern in a study area is represented by the trip matrix. Whatever study area we have taken, right, in that, say for example n number of zones we have made, right? So these zones are having generating certain trips and attracting towards the other zones. So those things are studied with the help of trip matrix or origin destination matrix. That is two-dimensional array of cells where rows and columns represent each of the zones in the study area. So here the horizontal axis of the matrix is represented by the trips being attracted, and that is D, and we are making zones 1, 2, 3, 4 like this, n number of zones, and vertical axis it is represented with the origin. So here you can see clearly in this matrix. So horizontal, that is trips attracted, and trips originated. That is, here it is written origin and destination. Means zone 1 is the origin. So, for example, this is the home and this is the college, right? So, from home, you are coming out and making a trip to zone 2. Zone 1 is say Bhagyanagar, zone 2 is say Mache area. So here you are making a trip from this zone to this zone. So like that, n number of trips. Maybe your father may be making a trip from say Bhagyanagar to other say Udyanbag industrial area. So that is zone 3. So another maybe your brother or sister is working in or studying in other college, say it's a camp area. So that is one more zone. So like that we have made the zones. So one is the this is one zone, that is Bhagyanagar area. So evening what will happen? So evening from college you will make the trips to zone 2 to zone 1, that is return trip, right? Similarly, like this the trips will be. So it is just for uh, easy understanding we are made in the two dimension, that is horizontal axis as that is trips which are being attracted, and the vertical axis as the zones from which the trips being generated. Okay, like this it is made. So all both these zones are same. Zone 1 means same, zone 2 means same, but the thing is here it is originating the trips, here it is attracting the trips, right? Hope the things are clear. Like this, there may be n number of zones. So we are mentioning it as 1, 2, 3, 4, 5, 6. It may be like this n number of zones. So at the I am taking till J. hmm, J. And here, with respect to origin, 1, 2, 3, 4, 5, 6, till n number of zones may be there. That is ith uh, trip we can see. So if you want to mention this particular trip, this will be, so it is T43, it is written, right? What is this trip? Having fourth zone as the origin and third zone as the destination, or the trip originated from fourth zone attracted towards the third zone. Similarly, this one trip originated from the sixth zone attracted towards the zone 2, Tij. Ti and J it is written. It is originated and attracted. Originated and destiny. Okay. What is this? That is the number of trips. T is nothing but the number of trips. So like this, we can write it for nth trip also. Nth trip will be, that is T ith n trip divided and till the T jth end. Hmm. So last trip will be Tij, Tith and nth trip. So like this, you can make the number of trips. And once, if you want to calculate total number of trips generated from zone 1, how we can calculate? Just you need to sum all these trips, whatever value it will be coming. No, these are nothing but the trips generated from zone 1. If you make sum of all this, you will get the trips generated from zone 1. Like this, you can calculate for all the zones. And if you want to calculate total number of trips attracted towards zone 1, is nothing but the sum of all these members. This is trips attracted towards the zone 1, right? It is very simple. So here to calculate this trip distribution, the methods of two types of trip distributions are there. That is growth factor method, and second one is synthetic method, right? So these are the two very important uh, trip distribution methods. So this growth factor method are based on the assumption that the present travel pattern can be projected to the design year in the future by using certain expansion factors. Right? So whatever present travel pattern is there, for example, from zone 1 to zone 2, certain numbers, say some 50 number of trips are being generated. So zone 1 to zone 2. So if you want to write in number of trips, for example, if I am writing 50, so in OD matrix, if you want to write, how will you write? This is origin, this is destination. Zone 1, 2, 3. Zone 1, 2, and 3. From 1 to 2, how many number of trips? Zone 1 to 2, 50 number of trips are being generated. So for example, 1, 2, 3, some 70 number of trips are there. So 1, 2, 3 is 70 number of trips. So like this, we'll make the, we'll prepare the matrix, right? So this is OD matrix. So like this, what we are doing, this growth factor method, here we are present travel pattern. So presently these many number of trips are there, and that is designed for, this is a 2020, and for next 10 years if we are designing 2030th year, hmm, for the future trips, uh, it is based, it is projected to the design year in the future. With respect to the present data, we are predicting it for the future, hmm, by certain expansion factors. So certain expansion factors may be with respect to, that is, that will be dependent on the, what is the population growth rate, population growth rate, vehicle registration, how the vehicle R density is growing, right? So how the, yeah, different that particular zones are developing, right? So depending on that, you'll calculate certain factors, and those factors are multiplied with the present trips to calculate the future trips. For example, this is factor which you get is 2, then it will be future trips will be 100 and 140. So like that, we can predict it. Got the point? So that is growth factor method. So here it assumes that in the future trip making pattern will remain sustainably the same as today, but that the volume of trips will increase according to the growth of generating and attracting zones. That's what I told. So with respect to the zonal growth, that is, here they have mentioned, pattern remains the same. Pattern remains the same means what? The between zone 1 to zone 2, zone 1 to 3, zone 1 to 4, zone 1 to 5, the different those pattern remains same, but the volume of trips will increase, and that is dependent on the growth, that is growth of the that particular zones. That is, if the area is sophisticatedly developed, or industrial area is attracting more number of industries and all, then obviously the number of trips will be more, right? The drip generation and attraction, for example, uh, that zone 1 is a residential area is there. Earlier, only individual bungalows were there, and because of the demand, certain contractor will come and he will demolish the individual building and he will construct the apartment. So obviously, the population density here earlier in that area, hardly some 6 to 10 members of a family, single family, say some 6 to 10 members used to stay. But when they constructed apartment, instead of 6 to 10, it is increased to 60 to 100. They will construct, say, some 4 to 5 floors bungalow apartment, and that is divided into, say, some 5 to 10 apartments. So each apartment, if you consider few number of family members, obviously the number has increased. So the number of trips being generated from the same small area has increased. Getting the point? So here the number of trips have increased because of the growth of that particular zone. It is generating more and it is attracting more. For example, in that particular zone, say some school, college, hmm, or industry comes up, then obviously it is attracting more number of students or employees. So like this, the growth will be there. So here, these methods are very simple than that of the synthetic methods, and it is applicable for small towns where considerable change in the land use and external factors are not considered, and they have often been considered it is adequate. Hmm. So growth factor method have been used in earlier studies, but have yielded uh, placed now to the more uh, rational synthetic methods because of what we see in the last few decades, the random growth in the traffic pattern. So growth factor method is in general, if you want to understand, it is very simple and simple method of trip distribution. Growth factor method is, it is a simple method. It is adopted for small towns, and it is applied with respect to the same travel pattern, travel pattern, but the growth of different zones, it is considered for calculation of the factors which we multiply to calculate the future trips. Getting the point? So growth factor method is simple, applied for small to medium towns where there is no large major changes with respect to land use and external factors are not considered, and it is uh, applicable with respect to where you have same travel pattern with different growth zones, right? So here different methods are uniform growth factor method, average factor method, Frater method, and furnace method. These are the four methods. Uniform factor or constant average growth factor, Frater growth factor method, furnace growth factor. These are the four important methods. Very, very important from exam point of view. Okay.